Our next speaker, we've got Karl, who is fresh from his quarantine haircut. Um, Karl has been working for about 20 years now. Companies all shapes and sizes, as well as across multiple sectors. 2 years ago, Karl made the jump across the board, Gáis as a senior development manager, and in doing so, plunged himself 2 feet into the serverless world and hasn't looked back since. Karl's going to run us through how peaceful and how easy it is to shift across the serverless architectures. I'm sure he's plenty of interesting stories. He's going to give us the pros and the cons, what works, and if you come back, how we go about it again. So without further ado, I'll hand you over to Karl. Going to run through the next slides.
All right, Sean, thanks very much for that. Thanks, Javier, as well. That was a great presentation. Thanks for blowing AWS Serverless out of water for us. I'm going to share my screen here now. Let me know if you can see it. Okay, so I'm Karl Kyck. I'm from Gáis Energy, and I'm here to speak about some of the mistakes that we made when adopting a pure serverless architecture on AWS. Made quite a few mistakes. They're a little bit embarrassing, so I'll go through this pretty quickly. And if you have any questions, please feel free, but go easy on me. So set the scene. So this started out as a digital services transformation project, which really meant that Gáis had this horrible legacy website maintained by a third party sitting on a traditional data center. It's taken like 2 weeks to make a simple change, and it's costing a bomb to run this thing. And they want to take that and rebuild it completely on serverless architecture in AWS. So somehow, somebody managed to convince them that AWS serverless was the answer to all of their problems. So that's how this started out for us. And this being us being new to serverless, we decided to start with a small but important web app for Gáis Energy. It's this web app that allows them as an energy provider to publicly publish remit notifications. So it's a regulatory thing. So for our first web app, we built the backend using the serverless framework to provision a Lambda-backed API gateway, so RESTful services, just the kind of thing that Javier was saying not to do in a way. And then on the front end, we were using React, which was served by CloudFront with an S3 bucket origin. So that brings me on to our first mistake that we made when we were building this thing out. And that was creating resources using the AWS Console. So at first, well, this is good for experimentation inside AWS and that. And it got us up and running really quickly. But when it came to replicate our application in different environments, so going from dev to pre-prod to production, we soon realized our mistake. Having to do that kind of thing manually using the AWS Console is a real nightmare. So it is. It's tedious, it's going to consume your time, and it's prone to errors because of inconsistencies between environments and naming of things, and etc. So especially when you're creating things like complex things like VPCs and subnets and security groups. So we solved this particular problem by going with CloudFormation. Obviously, we're using CloudFormation to model and provision our resources. And nowadays we use CloudFormation for pretty much everything that we do. Even those things that aren't supported natively by CloudFormation, we will use custom resources to do that. And there will be more on custom resources later on in the talk. So we will move on to mistake number 2. So this is pretty embarrassing. So we didn't use CICD from the start when we were making this first app. And that meant manually running the serverless CLI to deploy resources and copying HTML, CSS up to S3 buckets and things like that, and then running the test before deployment. When instead, what we could have been using was a fully managed CI/CD tool called AWS Code Pipeline and Code Build to do all of this kind of stuff for us. The thing about Code Build and Code Pipeline, you can define them in CloudFormation, so it makes it pretty easy to replicate existing pipelines and to create new ones from them. So why we didn't use it from the start, I don't know. Probably thought we didn't have time, but then again, we didn't not have the time to do it. So these services are pretty basic, but they are quite powerful and they've been working well for us ever since. So with the fresh success of getting that small web app out the door, we moved on to the main website, thinking that all our mistakes were behind us, when in fact the opposite was the case. So the second app, the main public-facing website, is what we tackled next. And of course, this time we were going to ditch the serverless framework on the back end, and we were going to adopt the AWS serverless application model, so the SAM, to build out the application on the back end, simply because it was it's native to AWS. It's their offering, so we had to go with the official tools. And of course, we're using CloudFormation for everything going forward, and we are also going to use CoPipeline, CoBuild to do our CICD. So that runs on to the next mistake, which was hitting this CloudFormation stack resource limit. So CloudFormation has certain limits, and well, we hit them at exactly the wrong moment that you'd want to hit them. So us being new to it, we threw everything into this massive monolith CloudFormation stack from the very, very beginning. And I think it was something like 2 weeks before go live, we were hit with a hard limit of 200 resources per stack. So we got hit with this thing. To give you some context, one Lambda in SAM creates something like 5 resources under the hood. So once you start stacking that up, all the Lambdas and then all of the buckets and various bits and pieces that you've got going on in there, we hit that limit right at the moment we didn't want. So we had to scramble to split those stacks. And now we were left with 2 API gateways, so 2 endpoints, and a bunch of shared resources that had to be split out as well. So we learned in that instance that serverless on AWS lends itself to microservices to split things out properly. So that leads me on to mistake number 4, which is the mixing of resource volatility. So resources that change together, they should stay together really. So API gateway, Lambda, those kinds of things in together, and any kind of resources that you need to support those internally. And then things that are shared should get their own stacks, so S3 buckets, databases, VPCs, all that kind of stuff. It'd be better to split them out into their own stack and then reference them from your main stacks. We of course, we split the stack, and then we ran straight into this problem because the S3 bucket over here was needed by both, and there's a few different things that happened. So it was pretty stressful at the time. So a little bit of planning up front could have saved us a lot of pain later on. So we'll move on to mistake number 5. This one, we still haven't kind of solved this well yet, but I'll run you through it anyway. So parameter store, so it's populating Lambda environment variables from parameter store. And parameter store is a managed service that lets you store configuration data and secrets in AWS. And you can reference those values in CloudFormation and assign them to Lambda environment variables during deployment. So it sounds great in principle, but in pain, it's a real pain in practice. So, and I'll tell you why now. So parameter store values are versioned. So every time you change one, it ups the version number. But you have to hard code the version when you're referencing it in CloudFormation, which means that at some point, your different environments are going to have different version numbers as you go. So that means then that to get that kind of consistency across all the environments, you have to blow away all the parameters and then load them up again at version 1, and then your CloudFormation stack would be able to deploy properly. We solved this particular problem by using Secrets Manager. So what we do is we load in the configuration from Secrets Manager that way. The problem here is further problems for that is that it adds a HTTP call to a cold start in Lambda. And then the configuration is cached locally in the Lambda. So in order to pick up a new configuration, if you change the configuration, you want to pick up a new one, you're forced to cold start that Lambda again. You're forced to make that Lambda cold start to pick up the latest config. And then the max size is like, for a secret, is 4096 bytes. So I don't know if there are any other ways to do this. Maybe you could do a timer, something like that to time out the cache. Maybe you guys have come up with a better way. So if you do, please throw it in the Q&A there, and most grateful. I see that the poll just came up there, so we'll see the results of that in a minute. Moving on, Oh yeah. So this is CloudFormation parameter store reference. You can see the version numbers being hard coded in there. So we'll move on. The CloudFormation custom resources. Right, yeah. So I mentioned that earlier on. We're using CloudFormation custom resources for things that CloudFormation doesn't currently support. And there's CloudFormation custom resources are great, but they have their own problems. So it's a blessing and a curse. You can control the provision and resources and provision what you like, but there are hidden traps. So no matter what happens, the custom resource Lambda that you use has to make an asynchronous call to signal either success or failure when it goes to either create or delete or edit a resource. If it doesn't make that request, so if some problem in your code doesn't catch an error condition or something like that, then you can block your CloudFormation pipeline and stack from deploying for hours. So to give you an idea, at one point I did something stupid. It was, I got the code URI wrong for the Lambda. And CloudFormation was trying to execute a Lambda that didn't exist. So that locked up our pipeline for 3 hours. And then I went in and I fixed it. And I went and locked it up for another 3 hours. So when creating custom resources, it's probably best to create them off to one side in a separate stack and do your own little development. And then when you have that just right, bring it back over. And hopefully you don't make any copy paste errors or whatever it is, bringing it back. There are helper libraries to help you avoid some of these mistakes, but not the code URI one. That was all me. That was my fault. All right. So moving on to number 7. Yes, code pipeline 1000 character limit. So we like to have environment agnostic CloudFormation templates where we pass in parameters to control target environments. So we could spin up multiple stacks in the same account if we want, or across different stacks, but just by controlling certain parameters coming in. However, code pipeline has this 1000 character limit for parameters passed into a stack. So we got hit with this at the wrong moment again. We maxed out all of our parameters at one stage. And the way that we got around it was, well, obviously reducing the parameter sizes. There's a little trick to doing that. There's certain things that if you say this here is an API gateway URL, you might be passing that to a particular stack for some reason. Well, instead of passing the whole string, you can just say pass in the REST API ID and the stage name. The region is already something that the CloudFormation has access to when you're running that CloudFormation stack. So that's one little trick. And then another trick is to have mappings in the target CloudFormation template. So you, instead of passing parameters, you set up this mappings and they're keyed off of, say, the environment target. So you can see here I have my env map and I have my dev environment, and then I got my value, and then you reference it using find in map. Problem here is that, well, obviously you need to contaminate your target CloudFormation stack with your target environments, and all the environments have to be specified in the parameters or in the map here before you can proceed. So you can't just spin up a new one for a new employee who's starting, a new developer who's started. You have to go in and code this in. All right. So mistake number 8, which is CloudFormation throttling. So normally you don't really hit stuff like this unless you're creating a lot of resources at the same time. And of course, this did happen to us because I think we were building out 2 or 3 new microservice environments all at the same time, trying to provision them to get up and running on another project. So we got hit with this, too many resources trying to be created at once. CloudFormation didn't like this, throttle us back. And then in this particular case, we had to retry and retry. So I'm not sure what to do about that. Maybe just planning your rollouts a little bit better might solve this problem. And then mistake number 9, the last one in this session, which is running serverless locally on your machine. This one here, we still haven't really solved this problem either. It's a tough one for serverless in general. But at first, we built Lambdas in such a way that it's very difficult to bootstrap them on their own without the handler. But we remedy that by writing code that can run independently from the handler. So it is possible to bootstrap your code and hook into AWS services and run your stuff locally if you plan it well. How do I do that? And it's also possible that to hook in with the existing services using your local credentials when you run it locally. So here's an example in JavaScript, TypeScript, where you're pulling in your local configuration or profile from your credentials file. And here's another one where you are setting up your environment variables with the region of the profile there too. We found that sometimes this works, sometimes that works, sometimes it's a mixture of the two, but there are ways around it. Another way to get up and running locally is the SAM local, which is pretty cool. So SAM local is like a serverless environment in the Docker on your machine. Unfortunately, it can be very slow and it doesn't support all of the services just yet. So I think a mixture of the two are pretty good, because what SAM is good for is validating your SAM templates before deploying them up into CloudFormation. So it'll save you an embarrassing PR where you're trying to tweak things in order to get your stack to deploy. And that is it. So far, we're enjoying serverless. It's pretty good. I wouldn't say it's no ops. There's still, you have to put thought into it. Somebody has to provision all this stuff. Someone has to think about all these things. But here are some of the things that we found with it as we're living it over the last 2 years. And that is what deployed yesterday won't necessarily deploy today. So at times, AWS upgrade services and they update certificates, things like that. They might deprecate SDKs. And they'll warn you. They'll give you good, they'll warn you in advance. But it's up to you then to go and update your application and make sure that you're up to speed. And then only then can you deploy again. So literally, say, for example, now the CloudFormation domain name aliases, all of a sudden you couldn't deploy anymore because you had the alias specified to one CloudFront distribution. And then, of course, they deprecated Node 8 there the other day, and you couldn't deploy any new Lambdas with Node 8. So on the one hand, it's good because it forces you to keep your applications up to date. And on the other hand, it can be a timing issue there sometimes. So it can be a bit of a pain. Other things that we found were odd bugs and behavior. There was a situation where every other deployment would fail for some reason. And we had no idea what was going on. It turned out to be a bug in AWS. So this went on for a few days, and we raised a support ticket against them. And it took a few more days for them to figure it out and fix it. So that's just another aspect of what you have to deal with. And then, of course, you find yourself thinking, ooh, is it my code or is it AWS that's the problem here? And more often than not, it's your code. So stuff doesn't go wrong. Or if fairly rarely in AWS does it go wrong. So it forces continual maintenance of applications. And now we're much more aware of the AWS service limits that we have to deal with when we're using any of the services that we're using. And as a result, then serverless heavily influences our architectural approach. So the services and features, the quirks, the limits, all these kinds of things will have an impact on the way that we design our systems. You have to keep these things in mind when you design them. And that wraps that up. So if there's any questions or anything like that, I open it up to the floor. Oh,
Perfect.
here's our poll.
Get your polls to have a look at.
Oh, environment variables, cool. Parameter store, cool. Secrets manager. So it's a nice mix between those three. Yeah. Okay.
How much of that, Carl? That was very good. Enjoyed seeing, I suppose, you suffer a bit, how you kind of do it all, and
You're still suffering, man.
Good to hear. A couple of good questions have come through here. Anton's got going there. Have you and the team at Gáis and do you start kind of reevaluate how you're doing it? Are you still kind of, I know it's very much the vendor lock-in is there, you're fully committed to serverless, but you start to look at alternatives within the Lambdas to how can we get around that, whether it's native, K8, Kubernetes, whatever it might be.
It's a good one. It's a good one. Okay, look, we started this journey about 2 years ago. Like I said, serverless had been picked for us already. So we kind of just got landed into it. Was it right for the job at the time? I didn't think so, because the company forced you to use Lambdas and VPCs. So at that time, they hadn't fixed that VPC cold start problem where it took 15 seconds for a Lambda to start up. that based on that alone, it wasn't really fit for purpose. Now they've since fixed that. Are they bullish on it? Let's put it this way: it's the path of least resistance. We got approval to use it from the various powers that be in there, and it's very quick and easy to spin up all these different services, hook into them all, and get things up and running, and then out into production and serving our customers. So in that respect, I think it's brilliant. Also, I heard traffic isn't that steady, so there are spikes and things like that, so it's good for that too. Cold start problem and tickling issue has been solved by using that. It's not the concurrent provisioning, but there's another type of provisioning that you can set on it. For us right now, it's the right choice. Going forward, I have no idea.
You have to wait and see. It might be above your own pay grade.
Absolutely.
Fair enough. There was another one that came through from Pascal. It was with regards to kind of a trend that he's seen in the market with some, I suppose, more front-end focused developers being thrown in the deep end, asked to do DevOps and Lambda functions and so on. What's your own thoughts on this?
Right. This is pretty good, because the front-end guys, they took to this quite quickly. So the lads are spinning up. We're using what they call it, isomorphic rendering on the front end using React, right? And Next.js running on Lambdas, which is pre-rendering all of the content and then serving it to the client. And then, of course, React then takes over and is able to do its thing thereafter. And it's pretty cool stuff. And the front end guys put this thing together, and they were the ones who pushed it and got it out the door. So quite impressed with that. So yeah, I understand that yet another set of tools or whatever it is being thrown at front-end guys. But if you rise to the challenge, you can do some really interesting stuff with this stack.
Yeah, perfect. I'd one there. I know Owen was thrown in there just with what you had with parameter store and that, how to kind of do it. So I don't know if you had a chance to look at the chat just yet, but might be worth having a look at yourself. But when I kind of wanted to see, like, I know you obviously had these teething problems and getting spinning things up and so on. The kind of the key points and the key takeaways, if you were to go back and I suppose back to the future, tell yourself what you do, what are the key points you kind of address before kind of jumping into the serverless architecture world.
Serverless architecture. You can get it up and running really fast. CloudFormation everything. Right, so create it as infrastructure as code or whatever you want to call it, so that you can easily throw up new environments or just experiment. And the documentation isn't great. It's a bit arcane. You've got to go in there and kind of pick it away at it. So it's probably best to spin up little experiments. So I was talking about doing the local running serverless locally, which is quite difficult. What helps there is good testing, of course. But then if you're hooking into something new, whatever it is, spin up a little experiment, try it out there first, and then in your developer sandbox, and then come back to the main code. And of course, microservices. So identify your aggregates, split them out with domain-driven design, all that kind of stuff. And after that, you will start running into some quirky stuff, but there is always a way to get done what you want to get done using serverless. It's like the Lidl of the shopping centers. You go in, you can only pick this product, but you know exactly what you're getting, and that's how you're going to do it.